In this video, I'd like to talk about the math question of the day for Sunday, April 30th, 2023. And with this problem, we need to compute the double integral shown below over this region where the x values, we can say this is x1 and x2. The x values go from -1 to 4, and the y values go from 2 to 3. And to answer a question like this, you will need the tools from calculus. And in particular, this is usually taught in a Calculus 3 class, or it might be called a multivariable calculus class. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start working through it. And it will first be helpful to remember what a double integral is actually computing. So for starters, we have this region, which is a rectangle on the xy plane. We know that the x value starts at -1 and goes to an x value of +4. And we know that the y values start at 2 and go to a y value of 3. So we can draw in this rectangle here by use dashed lines. And actually we could use solid lines since the border of this region is included. And essentially this function here, this 12x minus 18y, this is a function of two variables. We can also assign it the letter z. But this function, since these are linear and we are subtracting here, or if we were adding, we have the equation of a plane. So let me quickly show you what that plane looks like using a graphing tool. To graph this equation here, we're using the website GeoGebra, which allows us to graph things in 3 dimensions. And this equation, this function here of two variables, like I mentioned, is just the equation of a plane in 3D space. And we are looking at this plane on a very particular region when x is -1 to 4 and y values between 2 and 3. So it's a rectangle right in this area. And basically what the double integral is actually calculating is the volume underneath this plane here between the xy plane and this plane in that rectangle. So we're finding the volume of a specific region. So let's now go back to our blackboard now that we can roughly understand what we are actually finding. And when looking at our double integral, this dA is the area differential. Essentially, it's a small square in here where its horizontal component is dx and its vertical component is dy. Now I've drawn it bigger than it actually would be, but just so that we can visualize it, this would be dA here. And essentially to find the volume under that plane, we multiply our area differential by the height of the function at some particular coordinate point within this rectangle. And then if we add up all of those products there, the height of the function at that point multiplied by the area differential, if we add up all of those in the rectangle, we can find that volume. But we can write that dA is just the product of dx times by dy, and we can write it in whatever order we want, and that will tell us how we actually evaluate this double integral. Now let's start actually evaluating this integral. We can rewrite it as the double integral of 12x minus 18y, and we have our dA, this area differential, and we just need to determine if we want to evaluate the integral with respect to x or with respect to y first. And in this case, it doesn't really matter. Both will be equally difficult or equally straightforward since we just have a rectangle. If our region was more complicated, then the order will definitely make a difference in terms of the difficulty of this problem. But since we have a rectangle, we can do x or y first, and let's just do x first. But one way to check this is to switch it and then do y first and see if you get the same answer. And since x goes first, we will have the bounds on this inner integral going from -1 to 4, and the bounds on the outer integral going from 2 to 3. And essentially, the way to interpret this is that we will fix y, since we're doing that second, we will fix y at some particular value. It will be a constant in the integral, and then we will integrate with respect to x underneath this curve here, this plane in this particular instance. And then once we evaluate, let me rewrite that without the line tool. Once we evaluate this inner integral, then we will evaluate the outer integral with respect to y. We will essentially look at all the y values going from 2 to 3 and sum up all of these inner integrals in a sense. So this is called an iterated integral. We do the inside integral first. We hold y constant since we are integrating with respect to x, and then whatever value we get for that, then we evaluate the outer integral with respect to y. Though in that case, we will no longer have x inside the integrand because it will be evaluated inside this inner integral. And like I mentioned, if the bounds were more complicated, if we were looking at some type of curve, then we would need to be much more careful in choosing the order here. And with our bounds, they might be in terms of functions rather than numerical constants. So with this inner integral, we'll just rewrite the outer one. We are evaluating this with respect to x while treating y as a constant. So this entire term here, minus 18y, you can think of that as just some number, and we will integrate a constant in that case, and it's integrated with respect to x. So let's start with this linear term, 12x. We use the power rule. We increase the exponent by 1 and then divide by that new exponent. And for our constant, we will now multiply this by x. We essentially have x to the 0 power here. We increase the exponent by 1 and then divide by that new exponent. And we just need to evaluate this integral between the bounds of -1 and 4. So let's keep working on that down here. And we can simplify this fraction, 12 over 2, that's just 6. So I will rewrite the outer integral going from 2 to 3. And we can now evaluate this inner integral. We plug in 4 first. We have 6 multiplied by 4 squared, or 6 multiplied by 16. And then we subtract 18y multiplied by 4. And we subtract all of this evaluated at the lower bound. We plug in -1 and square that, we get +1, so this is just 6 times by 1. Then we have minus 18y multiplied by -1, so it becomes plus 18y. And we just need to simplify all of this and then evaluate that outer integral with respect to y. This 6 times 16, that is just 96. 4 times 18 would be 40 plus 32, that's 72y, and we're subtracting that. Over here it's already simplified. So we have 96 minus 6. We'll just rewrite the bounds for the outer integral. We have then 90, and we have minus 72y minus 18y, which would be minus 90y. And now that we've simplified that inner integral, we can evaluate the outer integral with respect to y, and notice that it no longer has x in it since we were able to evaluate that integral. And we'll just apply the power rule like we did above. This essentially is y to the 0. So we will get 90y to the first power. We divide it by 1, so we can just leave it as 90y. Then we have minus 90y squared, and then divide by that new exponent of 2. And we evaluate everything between the bounds of 3 and 2. So let's continue that down here. We can plug in 3 first. We have 90 multiplied by 3 minus 90 multiplied by 9, all divided by 2. And then we subtract at the lower bound. 90 times by 2 would just be 180. And we subtract 90 multiplied by 4 and then divided by 2. So that's just 90 times by 2, which is 180. So this second part will simplify to 0. And we get 270 here minus 90 times 9, which is, 810. And we'll divide that by 2. So we have 270 minus 405, which simplifies to minus 135. So this should be our final answer. And let's go back up so that we can better understand our answer. So remember that this integral, this double integral, finds the volume underneath this plane here between the xy plane and the height of the plane, or essentially the z value of the plane. And since we got a negative answer, that just tells us that on most of this region, or more than half of the region, the z values are negative. So the volume in those cases would be a negative number, though on some of it will be positive and they will balance each other out somewhat.